Okay, welcome everyone to my talk on PIACERE DevSecOps Automated. I'm Radosław Piliszek from 7bulls.com. I'm an IT solutions architect, and today I wish to talk to you about this PIACERE project, and soon it will become clearer what I mean by this project. But first, let me show you the agenda that I prepared for this very presentation. So first of all, I will explain to you what DevSecOps is, how we perceive DevSecOps here, what the PIACERE project is all about, what's the architecture of this project, and also we'll be diving into the bits of PIACERE itself. So, formally, as with everything in IT, there is some formal definition to DevSecOps. It has been taken from the Gartner's IT glossary, and this is how Gartner defines DevSecOps. So I will read it for you now. So the DevSecOps is the integration of security into emerging agile IT and DevOps development as seamlessly and as transparently as possible. Ideally, this is done without reducing the agility or speed of developers or requiring them to leave the development toolchain environment. Okay, so this is quite lengthy. It should be obvious what they mean, but I also propose a simpler definition, uh, which is that the DevSecOps is about not forgetting about security when doing DevOps. And ideally, as Gardner also underlined, without slowing oneself down. Okay, so then again, why do we need DevSecOps? To answer this question, we should consider what was back then, so before the DevOps happened, and what happened when the DevOps happened. Okay, so back then, and oopsie, the time machine has failed as usual. So let me fix it a bit. Tinker, 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 and then we've got the correct one. So regarding the back then, we had some silos, and here it is in the picture. So usually the companies had something like this. So we've got the IT folks who were mostly about the hardware itself back then. Then we had the sysadministrators who were mostly about Windows, Linux, and configuration of this, possibly also databases and stuff. Then we had network admins, which configured the routers, switches, etc., firewalls, and so on. Then we got some security government and governance teams, which actually created the different policies that were applied on the security side of the systems. Then we had the ops teams who coordinated the changes to the environment. And then we have the developers, the actual creators of the software that was deployed on the machines. So obviously not every company worked like this, and there were intermixing the roles as I present them here. But in general, the roles stayed separate. But then what happened? What happened is that we had DevOps movement. And the DevOps movement was mostly about removing these silos, so removing the boundaries between them. And thus, the developers that were siloed and they had to interact with other people to get their software deployed were actually now empowered to do this on their own. But on the other hand, while they became the controllers, we kind of lost this with the boundaries, with the silos. We lost some of the control over the process, in fact. And the community actually asked to bring the security back into this movement. And bringing back the security into the DevOps movement is precisely what DevSecOps is all about. So it comes at a cost, actually. We've got lots of tools already that deal with DevOps itself, that deal with security in DevOps, and so on and so forth. We have the tools for tools, and the tools, and they have the config, etc., etc. For each tool, we have some learning curve. The technologies underlying those tools could also impact the way that they are learned. We have all those ripple effects with heterogeneity. in current deployments where we have multi-cloud, hybrid clouds. We have some on-premise, we have something in a public cloud provider, or maybe we have multiple data centers that we need to interconnect. All in all, there is a lack of standardization in terms of DevOps and DevSecOps especially. And here a little slide about what we mean by DevOps. So there are two sides to this coin. One is the culture, the mindset. So the culture, the mindset is something that we try to treat with the dissemination of the project, with the presentation that we are making. But the project is mostly actually about the tooling. Most of the time when we mean by DevOps, we mean the tooling for the DevOps. And now a little slide about the back to basics. So this is probably obvious to you. I mean, in this OS community, and I'm presenting to this time. But there is this basic notion of CIA in security. So we've got confidentiality, integrity, and availability. But normally, when you talk to someone that is not strictly about security or maybe is new to the field, they mostly think about the confidentiality. Then, if you are lucky, they think about integrity of the data. But the availability is something that is often forgotten when it comes to security. And also, we would like with this project to underline the importance of availability and the different aspects of the availability that are relevant to the infrastructure. Okay, so with this preparation, with this, I I am now able to introduce to you the PIACERE project, and the PIACERE project is actually an acronym. This stands for the Programming Trustworthy Infrastructure as Code in a Secure Framework. So don't you worry, this is not as we all do on the old continent with the acronyms for the project names. But this is something that happens often in this European Union project, that we take very complicated long names and make up nicer sounding names for those. And piacere is actually an Italian word for pleasure. So in Italian, when you say piacere, you mean pleasure. And this project as a whole is proposing a framework precisely for infrastructure as code, and doing it securely, doing it trustworthily. Okay. So as I mentioned, European Union, yes, this is Horizon 2020 project in software development call. So this is something that the European Union offers participating countries. In that we have grants for the development of such projects. These projects are handled by consortiums. This particular consortium consists of 12 organizations, and the organizations are from different fields, from academia, business, and government. The schedule for this project, we started in December 2020, and we are finishing by the end of November 2023. So we are past the middle of the project, let's say. And we, as in my company, DOML.com, are responsible for integration and Canary Sandbox Environment, which I will talk about later. And the goals for this project is to focus on the infrastructure as code, the IAC only, to avoiding snowflakes and related config drifts. Deploying this infrastructure for applications, being able to manage cloud, hybrid, and multi-cloud deployments, optimizing usage of resources, enabling dynamic testing of IAC, and keeping the infrastructure turning happily. So these are the goals of this project, of this framework. Basically, grabbing some IAC, creating some IAC, then enabling the running of this IAC both in production and some testing environment, being able to monitor and react to changes in that environment, optimize it, and focus on cloud, hybrid, and multi-cloud deployments. Okay. And the key features that we derive from those goals. First of all, this is around GitOps. This is also some new kit on blocks. With the DevOps, DevSecOps culture, we have also the GitOps when we focus on the single source of truth, where everything is, every definition is actually tracked in a Git repository, where we also have single way of controlling access and accountability. So all the actions actually go through that Git repository. Um, in PIACERE, we integrate the security principles and tooling into the DevOps operations that we offer. We also propose a sandboxing guide to let the users test the dynamic properties of the to-be deployed infrastructure. We are cloud agnostic, multi-cloud capable, so that we are not focusing on a single provider, we're focusing on multiple public providers and also private providers such as OpenStack. We offer automatic healing and optimization of the resources, and we reuse and enhance open source. So there are many open source components that are actually being used in the project and that are being enhanced via this funding. And considering the DevOps continuum with infrastructure as code as PIACERE perceives it, so if you recall this figure, it's actually pretty well known, but if you don't, then it starts in the middle with the plan normally. So in the middle you have a plan, and regarding the plan, what we do as a PIACERE project, we support this modeling of the infrastructure so that it can be used in further steps of the continuum. For example, in creation, this model is transformed to something that can be used as a code, as infrastructure as code. Then we have verification phase where we check it for coherence, we check it for security. Then we have the packaging, and for packaging and release, basically this is a push button situation. But we also offer to run it before running it in a production environment. We offer to run it in a sandbox environment. Then we orchestrate the run on the production environment, and then we continuously monitor the IAC at runtime. We monitor the security, the performance aspects of that, and we propose optimization so that the continuum continues, as the name suggests, with the plan, the new automated plan proposed for the user. And by we, as I'm used to saying we, I mean the PIACERE framework, of course, not we as human resources. A quick look at the architecture of the PIACERE framework. So we have two clear phases, the design time phase and the runtime phase for each project, and it all starts with the IDE. In the IDE, where we have the tooling to actually do the DOML modeling, and the DOML is the language that we propose, the DevSecOps modeling language that is used to describe the infrastructure. This model can be checked with the DOML model checker, which checks for coherency and security issues that can be detected at the level of the DOML. Then we have the infrastructure code generator, which converts it into some runnable IAC, think Ansible or Terraform. Then we got the IAC scan runner, which is running scans of security type, of quality type on the generated IAC. And then when it's done on the design phase, on the static analysis phase, it is being pushed into the Git tooling, the infrastructure as code that is going to be deployed, where it's picked up by the PIACERE runtime control, which then orchestrates all the other steps in the runtime. So basically, the execution of the IAC, ensuring that the infrastructure is being monitored, that we react to self-healing events, that the optimizations are proposed when they are needed, etc., etc. So for the details, I will have them in the following slides. Since this is recorded, if you're interested, you can pause, I guess, on this slide if you need a little more time on it. So regarding the DOML, the language that we propose, it's a cloud agnostic able language. And what we mean by cloud agnostic able is that we offer both elements that are agnostic to the cloud provider that the user is willing to use, as well as providing a way to use provider-specific resources. So thinking like if the provider is already offering some solution for scaling, if the provider is offering some specialized type of node, some specialized service, we allow this to be modeled. This is also extensible with the DOML extension mechanisms, but this goes much beyond this talk. What is in this language? We have multiple layers of modeling. We have the application modeling and infrastructure modeling. And furthermore, the infrastructure modeling, which we focus mostly on, is at the abstract level and at the concrete level. So the abstract level is environment agnostic. So it's entirely like saying I need this computer resource. And on the concrete level, I mean I need this kind of resource. It is going to be a virtual machine that is going to have this capacity, for example, right? And this DOML can be used to generate the IAC, as I mentioned, the ICG, the infrastructure, the, excuse me, the IAC code generator is actually able to produce executable code from the DOML language. And the toolbox to do the DOML modeling is available in an Eclipse IDE. So with the type hints, with the code completion, with diagramming of what's already included in the model, it's in the Eclipse IDE. Then after the model is created, we have tooling to do some static analysis on it. So first of all, the DOML model checker, which checks the DOML aspects which are possible to be checked at that level. And then whatever is generated with ICG can be verified by the IAC scan runner. The goal of those two tools is to verify the correctness according to select criteria and to ensure that the components that it is all free of known vulnerabilities and that it follows best security practices that are known in the field. Basically, it's a mixture of custom crafted, custom tailored code as well as a collection of open source tooling. Then moving on to the runtime, we've got the PIACERE runtime controller, which orchestrates it all in the runtime. It operates in the one source to rule them all fashion. So as I mentioned, around this Git repository, the GitOps movement. We've got single for operations when you push to the repository and you then get your deployment update this way. Single source of truth, of course, I mentioned that already. What you get is you get this simplified and streamlined access control. So you control access to your deployment, to the way it works, to the configuration that you have on your servers, on your machines, via this repository. Regarding the runtime control itself, it's based on BPMN, so the business process model and notation. It offers an extensible vernacular, making the PIACERE runtime controller very much extensible itself. And the PIACERE runtime controller, the PRC, has this feedback loop with the infrastructure advisor, so the one that is responsible for the monitoring, and also this control loop with the Git tooling, where it actually asks for the source of truth, for the truth, right? Okay, so regarding the infrastructure advisor, this is the part that is relevant for the monitoring. So it collects and analyzes the metrics and events that are related both to performance, that is telegraph-based, and security, which is WASU-based. And in here, a little pause. As I mentioned, regarding the availability in the CIA triad, beware that when we think about performance, we report this as performance monitoring because that is what the majority of market players understands it like this. But on the other hand, have in mind that the availability, the performance levels, the desired performance is very much about the security of your solution as well. Because if you consider attacks like the denial of service attacks, when it actually reaches the performance limitations of your current solution, then it's on the verge of performance limitations and the security issue itself. So considering situations like that, and in general that the business continuity of your service is um, very much related to the availability, to the way that the user perceive this software that you offer as being snappy or not being snappy enough to be used, you might be losing actual money due to that. Okay, so this is how we tackle this problem. This is carefully thought out to ensure the continuity, and the continuity is furthered by the self-learning and self-healing that is included in this infrastructure advisor component. The infrastructure advisor part, the controller part, the storage part, let's say, runs on the PIACERE. On the PIACERE framework, and then the infrastructure side is deployed during the IAM run. So when the IAC is being run by the IAC execution manager, then the infrastructure side, so the agents are deployed there on the machines. And the metrics and events are also saved into this infrastructural elements catalog, which I'll talk about in a moment. So here it is, the IAC optimization platform and the infrastructure elements catalog. This is to allow the optimization of the infrastructure based on collected metrics. So we know the events that happen, the alerts, the metrics of the infrastructure elements that we care about. So the infrastructure elements catalog actually has both the static information, for example, what kinds of virtual machines are available, what regions are available. It actually knows about the public cloud providers, the details, what they offer, but it also tracks the characteristics of the various kinds of components, so that they can be monitored as such. And this is at the level of the type itself, and obviously at each of the instances, right? Uh, Interconnecting things like how much does it relate to the location of that particular resource, or if it's not if it doesn't depend on the location, etc., etc. The optimization platform optimizes the trade-off of cost, performance, and availability. That is what mostly is considered in such cases. So we try to minimize the cost, we try to maximize the performance to achieve the desired level of performance, to achieve the desired level of cost, so that we don't go beyond some threshold, and also the availability as it relates to performance as well. And this is machine learning based. So the optimization algorithms run on data that has been self-learned, that has some predictions, so we can actually react. So again, we, meaning the PIACERE framework, can react before the bad things happen, right? Okay, and then for the other tooling, for the IAC execution manager, the IAM, this executes the IAC against the chosen Canary Sandbox production environment, actually understands the deployed infrastructure, what the elements, what the elements are of this infrastructure, so that the catalog can be informed. It supports redeployment, so including things like scaling or the movement of the deployment to a different type. So vertical scaling, horizontal scaling. Secure use of credentials is out of the box, so that we access the target environment securely. And finally, as it was mentioned, the Canary Sandbox environment, this is for this dynamic testing of the IAC before it hits the production. We have two main tools in here, the provisioner, where it considers the deployment of selected environments, so like OpenStack, Kubernetes in an opinionated way, so that it's easy to deploy and test the IAC in such an environment, and also mock load when we mock APIs of selected cloud providers to test some aspects of the IAC dynamically, yet not provision actual resources anyway. Yes, so I mentioned this is to test dynamic aspects. This is a controlled sandbox environment, so nothing hits the production yet. And the goal in here is to avoid the step learning curve and bring your own environment, bring your own infrastructure deployments, and also the costs of public cloud providers. So removing the costs related to personal training and usage of public cloud resources. Okay, and that's it from my presentation. This is where I will be answering questions. Thank you very much and see you there. Bye bye.